Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics, Paper 5-2 Probability and Statistics 1 for February-March 2025. Question 1 is coming from Probability Distributions. Jacob throws 3 coins at the same time. The first coin is biased so that the probability of obtaining a head when it is thrown is a third. The second coin is biased so that the probability of obtaining a head when it is thrown is a quarter, and then the third coin is biased so that the probability of obtaining a head when it is thrown is 1 over 5. The random variable x is the number of heads obtained. Part A shows that probability of x is equal to 2 is 3 over 20. Now I can draw a simple tree diagram. We can have a head here, then a tail. That is for the first coin. Then the next one we have head, tail, then head, tail. So this is how it is going to look like. Like that. So the first one, this is a third, that means this one will be 2/3. Then the next one, if the probability of obtaining a head is a quarter, then this one will be 3/4, a quarter, 3/4. Then the last one is 1 over 5, that means this one will be 4 over 5, 1 over 5, 4 over 5, 1 over 5, 4 over 5, the same thing here, and 4 over 5. So we want the probability that x is equal to 2 heads. So we can have head, then the next one is also head, then a tail. Now I can shift this one until it comes this other side, the tail. So plus the next one will be head, then tail, head. And then lastly, I can have the tail, head, and head. So where am I picking? I'm picking from here, head, tail, head, tail, head, then tail, head. These 3 here. So now we are going to have a third times a quarter, then times 4 over 5. Then the next one will be a third times 3 over 4, then times 1 over 5. And then lastly we have a tail, which is 2 over 3, then times a quarter, and then times 1 over 5. Then this one will give us 4 over 3 times 4, that is 12 times 5, that is 60. The next one is 3 over 60. The next one is 2 over 60. Adding everything together is 9 over 60. Of course, when you divide all through by 3, then this one will come to 3 over 20. So that is that. Then next, they're saying draw up the probability distribution table. Now for x, when we throw the coin, there's a possibility of us getting 3 heads. Okay, these are 3 heads. Here we are having two heads, then 1 head, 2 heads, 1 head, then 1 head, and then no head. Okay, that means the numbers that we are having for the random variable, we have 0, 1, 2, and 3. So probability of getting no head is actually probability of getting tails only. So this one is 2 over 3 times 3 over 4, then times 4 over 5. So 2 times 3, that is 6 times 4, that is 24 out of 60. You can simplify it or you can leave it like that, no problem. Then probability of x is equal to 3. Probability of x is equal to 3, that means we have head, and head, which is going to be 1 over 3 times 1 over 4 times 1 over 5, which will give us 1 over 60. Now I have for 0, I have for 3, and I also have for 2. That means the one which is remaining is for 1 head. So meaning I can just say that probability of x is equal to 1. I just say 1 minus all the other probabilities. For x is equal to 0, which is 24 over 60. And then x is equal to 2, which is 9 over 60. And then for x is equal to 3, which is 1 over 60. Remember, for any probability distribution, the total probability is always 1. Okay? So meaning we can have these ones added. This is 10 plus 24. That one will give us that 34. Now, this one is the same as saying 60 over 60. Then minus, this is 34 over 60. So 60 minus 34, that is 26. So meaning this answer is going to be 26 over 60. Alternatively, I would say probability of x is equal to 1 is going to be equal to, we have 1 head, so a head, then the rest are tails. And then you shift this one until it comes to the end. So you'll say the next one is going to be tail, then head in the middle, and then lastly you will have the tail, and then head, just like that. So the head here is a third, the next one, the tail is 3 over 4, then the tail for the next one is 4 over 5, then 2 over 3 times 1 over 4 times 4 over 5, and then the tail for the first one, the probability is 2 over 3, then the tail for the next one is 3 over 4, and then the head for the last one is 1 over 5. And this one will give us 12 here, then plus 8, that will be 20, plus 6 here, that is 26. So you still get the same thing, 26 over 60. And then the probability of x is equal to x. So we have 0, we have 1, we have 2, we have 3. Then the probability for x is equal to 0 is 24 over 60. You can simplify this one, okay? But even if you leave it like that, it's okay. They don't penalize you, unless if they say give you answers in the simplest numerical fractions. That is when you can be penalized for leaving these ones like that. Then the last one is 1 over 60. So this is our table here. Part C, given that the mean or the expectation is equal to 47 over 60, find the variance. Now variance is equal to the difference between the squared means, so ex squared, then minus ex here, then squared. And this ex squared is summation of x squared times the probabilities. Okay, all values of x times the probability. So we are going to have we have x is equal to 0, so we square each times its probability, which we got as 24 over 60. Then we have 1, we square each times its probability as 26 over 60. Then we have 2, we square it times its probability as 9 over 60. Then plus 3 squared times its probability as 1 over 60. So we can, of course, this one is 0 here. Then this is 26 plus 36. That one will be 62. Then plus 9. That one will give us 71. So we shall have 71 here over 60. So meaning the variance of x is going to be equal to that 71 over 60 then minus the 47 over 60, then squared. So putting everything in a calculator, what do we get here? 71 out of 60 minus 47 out of 60, then squared. So that is 2051 over 3600, which is 0.570 to 3 significant figures. So you can either write your answer as 51 over 3600, or you can write it as a decimal to 3 significant figures. Whichever you want, that is that.